Hello, and welcome to this talk on trends in high-performance computing, artificial intelligence, and cloud. My name is Andrew Jones. I work at Microsoft Azure, and in particular, I work on future capabilities for HPC and AI. The title of the talk perhaps needs adjusting a little bit because most of what I'm going to talk about is observations and predictions rather than trends. I'll start with some observations on where I think the technology space is now for high-performance computing and perhaps what that leads to in the future. I think we're in a lucky environment now, or unlucky depending on point of view, where we have a lot of options for HPC technology. So we have a number of genuine competitive HPC processor options from Intel and from AMD and from the ARM ecosystem. We have either now or in the near future a number of competitive GPU options for HPC. So obviously from NVIDIA, forthcoming from Intel, and obviously the AMD GPUs. We have a range of different interconnects, InfiniBand, the rebirth of Omnipath from Cornelius. We have obviously Gigabit Ethernet with low latency adapters and so on. There's a range of interconnect options. We have a range of different storage options from different file system types and even some non-file system based I/O, object-based storage and so on from Intel and from cloud providers. And that's before we even get into the software options and so on. So there are a lot of choices in HPC at the moment. That's good for competition. Competition is good because not only does it help drive the prices down, but perhaps more importantly, it helps drive innovation. Competitive pressures in a marketplace are one of the best ways to keep the technology providers and the technology creators and inventors driving forward and creating innovative new capabilities and advancing the state of the art. The downside of all of this choice options is, of course, uncertainty. Having to pick one of these for your next deployment. So you have to pick an interconnect, a processor, potentially a GPU, a file system, and so on. And navigating through the space of options to find the one that is the best in terms of performance, price, cost, risk, and so on, provides challenges for the users, the programmers, the system buyers, and maintainers, and so on. So there is uncertainty in our which way to go with HPC, how to get the best value out of our money. But our choices don't act in isolation because, of course, as well as trying to figure out which is the best technology, one of the things we're trying to do is also try and guess which technologies will still be around for the long term, or at least around long enough so that you don't end up being the only user of a particular technology that's long since expired. But of course, which technologies survive is not independent of our choices. So as we try and predict the sustainability of a given technology, if we all decide to buy it, that improves the sustainability opportunity or the chances of sustainability of that technology. Likewise, if we all decide we don't like the look of it or we don't trust its future and we decide not to buy it, then that is a self-fulfilling prophecy and that technology probably won't survive. So we're also then feeding back into the options for the future by the guesses and gambles we make about sustainability now and how we navigate our path through the uncertainty as well. So that's the space we're in at the moment. And I see that continuing for the foreseeable future. I don't see that range of options collapsing down to some simple, clear choices in the near future. When I think about high-performance computing for the medium term, I think there's a number of assumptions that I'm comfortable making, and that when I talk to others, I think others feel that these are similar as well. So these are both observations on the current state. They are what I see as trends into the future, and my predictions these trends will continue. Fine-grained parallelism is here to stay. It's here at the moment if you want the best performance, and it's going to stay. Now, whether that is GPUs on a node, or whether it is processors with lots of cores and then vector units on each of those cores and so on, also gives you a large amount of parallelism, or whether it is other new technologies coming out in the near future that are somewhere between a processor and a GPU in terms of their architectural characteristics and their performance behavior and so on. So I think we will definitely be assuming and working with fine-grained parallelism on the node, but we shouldn't necessarily assume that that will be GPUs as the only way of doing that. Thankfully, we're starting to see some innovations come through on memory bandwidth, and I think we can assume over the next few years that memory bandwidth, certainly at a local level, close to the processor, will be much better. Whether that's the HBM technologies, whether it's AMD's V-Cache technology, there's a range of different options, but the memory bandwidth will be better. However, it will still be a challenge. The economics mean that we won't be able to afford huge capacities of high bandwidth memory on a node. So there will still be capacity limitations and therefore performance limitations. So I think we need to be ready as buyers, as programmers, as users to make use of memory bandwidth when it's there, treat it as a bonus, treat it as a gift, and make use of it when be able to make use of it when it exists. But don't build in anything that totally relies on the memory bandwidth as the only way to gain performance. And then I think the next thing that we can assume, which again is a trend continuing from the current situation, is that managing locality, hierarchy, and topology is going to remain important to extracting the best performance from whichever HPC system you're using. So in other words, figuring out where your data is and what data is near it, what is the hierarchy of options where that data could be stored, and then what is the path between those different options, or those different locations of the data. So understanding that, managing it, exploiting it will be essential to get the best performance. And those applications and codes that do that well, or those systems that expose this and make this easy to manage, will do well. There are some other assumptions I would make as well. So for I/O, I think there are some opportunities coming through for new I/O-based methods. So for example, we've seen NERSC deploy the all-flash-based file system for their latest supercomputer. We have seen some more object-based storage technologies coming through from Intel and from cloud providers. So I think there are definitely opportunities and innovations in the I/O space, and I don't think it's that anything particularly stands out as an obvious game changer we're all going to jump on. I mean, there are clear both performance and cost benefits for using object-based file storage in some cloud situations, for example, and there are some clear performance-based advantages to using all-flash file systems, for example. I think it's more a recognition that as an industry as a whole, we still haven't really cracked the storage and I/O problem around HPC, and we have solutions at the moment, but I don't think anybody's particularly comfortable they're the right and the long-term solution. And so we'll continue innovating down that space. I'm pretty confident that whatever HPC system we'll be looking at for the medium term will be a Linux-based system. There will be options to run other operating systems, Windows and so on, but realistically, the dominant operating system is going to remain Linux as far as I can see. It will be capable of running Fortran plus MPI plus OpenMP. For Fortran, you can also read other very similar languages like C and so on. I think there's a reasonable bet that it will be able to run either directly or through some kind of translation layer, CUDA-based code as well, but I don't think that's as nailed on certainty as those other things that I've listed there. And then I would argue that almost anything else we're going to assume for HPC over the medium term, so not in the next year or two, but let's say the next 2 to 7 or 8 years. I think anything else over that time frame is either the subject of significant debate, still unproven R&D efforts, is just blatant guesswork, or indeed is product pitching. So if somebody particularly says that we're all going down the path of technology A, then I think if it isn't on the list, I'd be tempted to say that that is related to somebody's particular vision, dream, or product. Having said that, I do think we're overdue a new technology emerging in the world of HPC. So we go through these cycles every few years where we get a new technology coming into play, either from other parts of the computing space or from other parts of science where it creates a technology that becomes mature, etc. So I do think there will be, as I said, I think we're overdue a significantly new technology that will make a real impact. The photo here is actually of quantum computing. I don't think it will be quantum computing, certainly not on hardware terms. There may be influences from quantum computing algorithms, but I think in hardware terms, it won't be quantum computing that has the significant disruptor effect in HPC in the next few years. But I do think there's something else that will happen, something that we're not probably discussing very much in the community at the moment. And that's guesswork. I don't know what it is. I'm not thinking of a particular technology. I've just got an instinct that we're overdue some significant disruptive technology over the next 5 or 6 years. I think the other trend that the community is slowly working its way around and slowly learning is the recognition that HPC is much more than just hardware. We still see a lot of people talking about HPC standing for high performance computer, and people talking about supercomputer, but really the impact and the value comes when we change that to high performance computing or supercomputing, and we talk about how you use this technology, and you then recognize that it's more than just the hardware. You recognize that it's more than just indeed just the software stack. You get into people and processes and procedures around it, and how it's integrated into the business of the science, and how you actually extract the value and the impact from it, not just run a simulation on a machine. And perhaps a little frustratingly, some of this is still a little bit new and a little bit of a shock to some parts of the community. That the hardware is important, but it is still only a tiny piece of the overall pie with high performance computing, a piece of the overall ability to generate value. One of the other trends that I think is going to come through is both the evolution of the programming languages we're going to be using on the systems, and also the continuing trend to be debating programming languages. So within the high performance computing community, we talk about Fortran as the default language for most of what we do. Some of that is based on the large amount of existing code base in Fortran. Some of that is based on the fact that it just works and it's a good language that fits well with what we're trying to do with high performance computers in most cases. A lot of the rest of the computing world, I think we're bonkers trying to continue the use of what they see as an old language. And so I think there is a trend that we will see increasing numbers of people coming into our field, either fresh from universities or indeed coming from other sectors into the high performance computing world, where their primary experience will be languages other than Fortran. And I think that richness of extra diversity and opinions will start to evolve the choices of programming languages we use in high performance computing. I do think if I want to make an observation about a trend and a prediction about that trend for the future, we are still going to be debating the rights and the wrongs of different programming languages for at least the next decade. I don't see that going away and us making a magic decision on the perfect one. I do think that we're also slowly, and it is slowly, starting down a path of maturity around our HPC in terms of high performance computing services. So I talked about that evolution from high performance computers to high performance computing, the recognition that the machine on its own is not enough. We need to build services around the machine in order to unlock the science and the business and the engineering impact and value that they can generate. And I've been presenting a version of this slide or this message for at least 20 years or so. And in the early days, it was certainly working against an audience who were very focused on the machine, the supercomputer, as the thing that mattered. That conversation has moved on now, and the industry as a whole is much more mature, with other steps of maturity axis as well. For example, we now talk about total cost of ownership or total cost of solution around HPC rather than just the cost of purchasing the machine. So recognizing the cost of running the environment, the cost of porting applications to it and supporting it and so on. We're still not a long way along that path. So a lot of HPC sites will still use, will build a TCO calculation or a TCO model when they have a particular decision to explore or a particular point to make. It's still relatively rare to see the maturity step of a HPC service having a TCO or a TCS model, or indeed an application user group or developer team having a TCO or TCS model as an ongoing permanent part of their operational toolkit. so that the TCO model is always there and it's continually updated as part of the decision framework around the site. There still tend to be spot usage rather than, as I said, a core part of the infrastructure. The way we're looking at metrics is evolving over time. We are starting to learn that utilization is not a great metric for measuring value. We're starting to learn that things like price per core hour only works when you're comparing very light technology, and if you start comparing GPUs versus CPUs, or cloud versus on-prem, or supercomputers versus commodity clusters, then those very simple metrics like price per core hour break down because they don't properly capture the value side of the equation, or indeed the risk or sustainability side of the equation. So we're starting to get wiser. Again, very, very slowly, we get more mature than metrics. And of course, the goal as we work through all of this is getting towards having not only cost models, but value models and risk models of our HPC services as well. And we're also starting to see things around the professionalism around HPC. So things like the recognition of the RSE career path and research software engineering career path, which of course is broader than just HPC, but it's a recognition of the professionalism around that's needed around HPC services. I could talk about this live for a long time, but let's move on. I think the people side of HPC is also evolving. So we are seeing a number of changes come into play. So one of them is that clearly we are getting people coming in continually from not only from universities, so we're getting younger people coming through into the HPC world, but also we're getting people starting to be attracted into HPC because of adjacent sectors. So coming through from the cloud experience background, or coming through from the AI experience background, or indeed coming through from completely different backgrounds, not related technologies. And that's adding a richness of different experiences, ideas, and opportunities around where HPC can go and what is reasonable and what's achievable and so on. So I do think that changing people coming through will change some of our attitudes towards what's acceptable and what's possible with HPC. On top of that, of course, we're also starting to see people retire and so on. And the idea of having the bulk of the leadership and the practitioners of HPC made up of people who have grown up with HPC and the way it's being done for the last however many years, that's evolving over time, both with people moving on and with new people coming in. I think that is good for our community as a whole. There's some downsides that we're still not quite making progress on the people side of things. So, for example, we have made we've made some good progress around diversity and inclusivity and the people side of the HPC community as a whole. But I think it's fair to say there is a very, very long path to go there, and there's a lot more work to do. I think at least we've recognized that there is a path that needs to be gone, at least to be trodden there. But I think, as I said, there's a long path to go and a lot of work to do. Related to that change in people is there's different expectations around high performance computing now. So, for example, there's a much greater pressure on ease of access to HPC resources, a much greater pressure on ease of use of the resources, and a change in equation around what is an acceptable amount of pain and effort to go through in order to get the best possible performance out of a system. So if you go back, years or decades, depending upon your point of view, it was assumed that you would do whatever you needed to do to your application or to the application you were supporting on behalf of somebody else in order to get the best possible performance. So lots of tuning, lots of optimization, put a lot of effort into that. There's now much more of a balance between, and so even if that gave up on things like portability, so if it made it run 5% faster on this system, but perhaps less portable code, most people would go down that path in decades gone. We've now changed what's acceptable in that equation now, so that we're much more interested in finding the right balance between portability, performance portability, and the best performance on a given platform. And also the amount of human effort we're willing to put in and human time we're willing to put in to achieve those performance levels. So I think that is changing. Some of that is just the way that technology is changing. Some of it's a growing maturity of the space. And some of it is the fact that we have these fresh perspectives coming in from other people. Cloud is is here to stay. It is gone from being a relatively niche thing in the high performance computing community to something that is growing really quite significantly, and that significant growth really only started in the last year or two. In some respects, the common phrase "cloud is just somebody else's computer" is very true. I think it's important that we try not to ascribe any magic value to cloud. It is not some distant magic thing that just solves all of your problems. It really is just somebody else's computer in a data center somewhere else. But having said that, it's a bit more complex than that, because it is not only somebody else's computer, it is somebody else's lots of computers in lots of data centers globally available, with a whole load of other services around that, like storage and machine learning capabilities and so on. So I think that's important to recognize, that there's a lot more. The simplistic thing has value, somebody else's computer, but the reality is a lot more powerful than that. And cloud is enabling significant value for those who can adapt, or those who are willing to adapt. And part of the challenge there is that, as with any new technology, a lot of people are not yet willing to adapt, and in some cases not yet able to adapt to exploit the new technology. And cloud is no different from other new technologies in HPC in that sense. There are other things, cloud is not infinite in spite of marketing. It's not even virtually unlimited in spite of marketing. There are some real limits around it, but the scale and the breadth of capabilities there are substantial. I think it's also worth pointing out that the story around cloud has evolved at a huge pace over the last few years, probably even the last 2 or 3 years, to be honest. So we moved from an era where 2 or 3 years ago, on-premises was clearly the most economic, the most performant, and the most usable choice for HPC. There was no real question about that. When we are now in an era where both on-premises and cloud are viable options across all the axes of economics, performance, and usability. In a given case, one might be slightly better than the other, and so on, but it's very rarely a clear choice one way or the other. Now, one might win out on economics, another might win out on agility and business value, another might win out on usability, and so on. It's a much more complex story now, and both are viable options, genuinely viable options. And there's some visibility towards a future era where cloud could be the optimal model in most. In my personal view, it will never be all situations. But I'm not saying it's guaranteed to happen, but there's certainly a visibility towards that possibility of where the future will be the optimal model. But the important thing is we're in this era now where both are viable. That has been driven by the evolving technology availabilities, or the evolving product availabilities. It's also been driven by both needs and desires, and those two things are different, of the science and the business and so on, and by external market effects, vendor consolidation, the growth of the hyperscalers, and so on. There's market effects beyond HPC that have driven this possibility. It's very important that we recognize that cloud is no more of a sensible descriptor than on-premises, in that there is a range of different on-premises capabilities, whether you're talking about a commodity cluster or a supercomputer, whether you're talking about a CPU or a GPU. A lot of these questions are actually much more relevant to how you get the benefit out of your computing capability than whether it exists in your data center or my data center or somebody else's data center. So I think we need to be careful not to use cloud as a generic word, because not all clouds are the same. There is significant differentiation between the different cloud providers by choice. They bring in different strategies into play. And for example, it might be more important to the developer to know whether they're programming for a CPU or a GPU, rather than knowing whether that CPU or GPU is in an on-premises cluster or a cloud cluster. So we just need to be careful that we don't treat cloud as this generic thing, because it isn't. There are differentiations amongst the cloud providers that are significant and real. Artificial intelligence is still in the dawn of its applicability. It's already very powerful. It's already being used significantly, obviously in the world at large, but in particular in the world of HPC, artificial intelligence or machine learning is being applied for significant benefits already. I would argue it's still very much in its dawn, though, and a lot of people are experimenting with it rather than using it in production, trying to figure out where it genuinely delivers value and how to get the most out of it. but it is on a huge growth curve, and it's only going to get more powerful and more pervasively used. And of course, that drives the technologies that are used for HPC as this becomes a more, both in terms of a bigger workload, but also a more politically high-profile workload. And that has a significant driving effect on the technology that's available for AI, and therefore that's available for HPC as well. And then one other trend that I'll draw out. So we have in our community the top 500 list. I don't see that going anywhere. We all use it for marketing. We all use it for assessing real things such as the actual adoption of the technologies in our community, rather than measuring them by the number of stories about technologies in the HPC media and so on. By actually looking at top 500 list, we can see what's actually being deployed in the industry as a whole, and at what scales and what geographies and so on. So the list is very powerful beyond just the marketing and so on. And I think that top 500 list is here to stay with us for quite a while. But actually, the real point about this picture that I was trying to make use of is the person in this picture appears to be enjoying themselves, and I think that's an important part about HPC. In fact, I'll move to the conclusion slide really to make it. We're in this time now when high-performance computing is it's a time of fun. There is uncertainty. There's lots of choices, lots of new technologies going on. There are big questions around business models of cloud versus on-prem. There's new things coming into play like artificial intelligence. There are unknown disruptors on the way. So it's a time of fun. It's a time of uncertainty. In turn, that means it's a time of opportunity. And I think that spans wherever you are in the ecosystem, whether you're a customer, a buyer, a user, developer, technology provider, service manager, and so on. And I can only see that staying that way for a number of years. I do not see any reduction in that complexity and the overall fun of our sector for any time in the near future. And so with that, I'd like to thank you very much for your attention to this talk, and I'm available for any follow-up questions or discussions. Feel free to reach out to me on Twitter or LinkedIn or other means. Thank you very much.